Okay, so dear students, welcome to the lecture number 67, circle problem set we are going to solve from today. So, no matter first question is question number 1, you all know that MCQ type questions are there. But in this MCQ type of questions, it is very important to understand why that specific answer is there. There must be a reason. To know the reason is very important. Rather than simply writing these answers is not fair. So I'll explain you all the reasons for these MCQs. So first question is, two circles of radii 5.5 and 3.3 are respectively touch each other. What is the distance between their centers? So there are two possibilities are there. It is not mentioned over there whether they are intersecting each other externally or whether they are intersecting each other internally. So there will be two possibilities. Okay. So first of all, I am going to take R1. R1 as 5.5 centimeter and R2 as 3.3 centimeter. If circles touch each other externally, distance is equal to R1 plus R2. Distance is always equal to R1 plus R2. So that distance is equal to 5.5 plus 3.3. So that is equal to 8.8 centimeter. Second possibility is that if circles touch each other internally, distance is equal to distance between centers is equal to difference between radii R1 minus R2. R1 is 5.5 while that of R2 is 3.2. 3.3. So answer for this is option D. So first one, option D. Second one, two circles intersect each other such that each circle passes through the center of the other. If the distance between their centers is 12, what is the radius of each of the circle? Please try to understand this. I am going to draw two circles. If I take A, if I draw this, if I draw this, now this is a center of the other one. Try to understand. This is the center of the other one. So if I take this as point B, and if I draw other circle, if I draw other circle, then you will find this distance AB. AB is equal to struck centimeter. So from point B to A is a radius of circle with center P. As well as from A to B is the radius of circle with center A. So Question asked is, two circles intersect each other such that circle passes through the center of the other. If the distance between their centers is 12, what is the radius of each one of them? So radius of each one of them is 12. The radius of each circle is 12 centimeters. Third one is right. So 12 is option B. Correct option is B. Third one is a circle touches all the sides of parallelogram. So the parallelogram must be, what is the nature of the parallelogram? Supposing if you take this ABC is a parallelogram, try to understand this. Option is rhombus, but why option is rhombus? Now the circle is touching all sides of parallelogram. So quadrilateral. This is a parallelogram. Please try to understand. If I take this as x, this is also x. Reason is very simple. Tangents drawn from the same exterior points are congruent. Likewise, if I take this as y, this is also y. Reason is what? Tangents drawn from the same exterior points. Now you will find if I take this as y, then this is also 1. If I take this as x, then this is also x. Tangents drawn. But why I have to take this as x and y? Because opposite sides of parallelogram are congruent. And you will find if AB is x plus y, then naturally DC must be x plus y. Now you will find AB is equal to DC. AB is equal to DC. AB is x plus y. AB is equal to DC, that is y plus x. Both of them are equal. This is also x plus y, this is also x plus y. Correct? Because these are also opposite sides. So you will find that opposite sides are congruent as well as adjacent sides are also congruent. Because if this is x plus 1, this is also x plus 1, this is also x plus 1, this is also x plus 1. So you will find AB is equal to DC, AB is equal to BC as well as BC is equal to AB, and very important is AD is equal to DC. AD is equal to DC. If adjacent sides of parallelogram are congruent, then that parallelogram becomes a rhombus. That is very, very important to understand. If adjacent sides are congruent, then it is rhombus. So option for third one is B. So option for third one is B. Fourth one, length of a tangent segment, circle is given. Okay, try to understand the question carefully. The question is length of a tangent segment drawn from a point which is at 12.5 centimeter. So A is a point which is at 12.5 centimeter from O. Length of a tangent drawn is 12 centimeter. So this is 12. Question asked is find the diameter of the circle. So let's see here. You all know angle B is 90 degree. Angle B is 90 degree. Tangent radius 10. Tangent radius 10. So in triangle OBA by Pythagoras theorem, OA is hypotenuse, so OA square is equal to OB square plus AB square. OB square plus AB square. But OA is 12.5 square. That is equal to OB square plus AB square. AB square. 12.5 square is 156.25 minus 144. That is equal to OB square. Square of 12.5 is 156.25. So minus 12 square is 144. So if you take the difference, so if you take the difference between these two, you will be getting 12.25 is equal to OB square. So root of 12.25 is equal to OB. So OB is equal to 3.5. Square of 3.5 is 12.25. So you will find OB is 3.5. But what is OB? OB is radius. Question asked is find out diameter. So diameter is equal to 2 into 3.5. So diameter is equal to 7 centimeter. Option C for fourth one. Option C. Correct options. Fifth one. if two circles are touching each other externally. They are touching each other externally. Question asked is, how many common tangents? How many common tangents can be drawn? You will find common tangents are this way. This is 1, this is 2, and this is 3. So we find that how many common tangents can be drawn? L, N and N. 1, 2 and 3. So our answer is 3. So for fifth one, option is 3. Option is 3, C1, 7, 7. Okay. Now next question is sixth one. Angle ACB is inscribed in the arc ACB of the circle with center O. Okay, fine. So let's draw the figure first. If I draw this figure, angle ACB angle ACB is inscribed in the arc ACB. That is the condition given. Angle ACB is 65 degree. If I take this as 65 degree, question asked is, find the measure arc ACB. Try to understand. Question asked is, find the measure of arc ACB. Arc AB is equal to, measure arc AB is equal to, angle is half, so 2 into 65. So measure arc AB is equal to 130. Please try to understand. Inscribed angle is there. Measure of inscribed angle is half the intercepted arc. So intercepted arc is twice the angle. 65 to is 130. That is clear. So arc ACB is equal to, measure arc ACB is equal to, this arc we have to find out, 360 minus 130, because sum of all arcs of a circle 360. So measure arc ACB is equal to 230. Very important. Sixth one, option is D. Question 6. D, 213. Seventh one, Chords AB and CD of a circle intersect in the interior. Chord AB and CD are going to intersect each other. They are intersecting each other in point E. So if I draw AB and C, chord AB and chord CD are intersecting each other in point E. AE is 5.6. AE is 5.6. EB is 10. B is 10. C is 8. Question asked is find out D. Find out D. You all know chord intersection, chord internal division theorem. You all know it. So by chord internal division theorem, by chords internal division theorem, product of the parts of one chord from point of intersection. So AE into BE into BE, that is equal to product of the parts, that is DE into CE. DE into CE. Now AE, what is value of AE? 5.6. BE, what is value of BE? Is 10. That is equal to DE. We don't know the value of BE. But what is value of C is 8. So product of the parts of the one chord from point of intersection is equal to product of the parts of another chord. So D into 8. So here you will find 56. If you multiply 5.6 by 10, you will be getting 56. So D is equal to 7. D is equal to 7. So option A, 7. Option is A. That is 7. Next to that is question number 8. Please try to understand this question number 8 carefully. In question number 8, quadrilateral ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. Measure of A is twice the measure of A. So twice angle A is equal to twice the measure of A, that is equal to twice the measure of C. Twice measure of C. So you will be getting A upon C is equal to 3 upon 2. A upon C is equal to 3 upon C. So let angle A is equal to 3x and angle C is equal to 2x. since we got the ratio of A is to C is 3 is to 2. So generally we always take multiplicative constant. So I have taken multiplicative constant as x. So I will be getting A as 3x and C as 2x. You all know A plus C is 180. A plus C is 180. Opposite angles of cyclic quadrilateral. So 3x plus 2x is equal to 180. 5x is equal to 180. X is equal to 180 upon 5. So x is equal to 36. Question asked is, find out angle C. Angle C is how much? 2x. Angle C is 2x. So 2 into 36 is equal to 72. Angle C is 72. Angle C is 72. So for eighth one, option is B. Option is B. Here we finish 8th question. Now 9th question that I am seeing the type. Points A, B, C are on the circle. Okay, fine. You have to draw a circle. Points A, B, C are on the circle. It is given over there. Points A, B, C are on the circle such that arc AB, measure arc AB, is congruent with measure arc BC. So this is 120. This is 120. Sum of all arcs of a circle is 360. Therefore, arc BC is also 120. Try to understand this. If AB is equal to 120, AC is equal to 120, naturally BC is equal to 120. So, since all arcs are congruent, all sides are congruent. Sides means chords. Are congruent. If all these chords are congruent, triangle ABC is an equilateral triangle. Triangle ABC is an equilateral triangle. So this is the ninth one. 10th one. Question number 10. The last one. So option for this ninth one is A. For ninth one is A. Equilateral triangle. 10th one is right now, last one of question 1. Segment XZ is the diameter of a circle. Fine. Y is in the interior. XZ is the diameter. If we take XZ as a diameter, Y is in the interior. Okay, this is 90. This is 90. Now see the possibilities. It is not possible that XYZ is an acute angle. Yes, this is greater than this one because you will find for triangle XMZ is 90. This is 90. And this is exterior angle for Y and Z. So this is obtuse. This is obtuse. Try to understand. This is angle subtended by diameter. This is diameter. So angle subtended by diameter is 90. So this is exterior angle is greater than remote interior angle. So it is obtuse. So first one is, it is not possible that XYZ is an acute. That's true. XYZ can't be a right angle. Yes, this can't be a right angle because this is greater than 90. So it can't be a right angle. XYZ is an obtuse angle. Yes, absolutely correct. XYZ. So can't make a definite statement. Yes, we can make a definite statement that XYZ is an obtuse angle. So all three statements are true. A, B, C are true, or 1, 2, 3 are true. 1, 2, 3 are true. Question asked is, how many of the following statements are true? So option for 10 is C, only 3. So this is how you will find. I finished all MCQs. Let's do the question number 2. Can be a last question of this lecture number 67. Then I'll stop. Last question. Question number 2. Please make it correction over here. Please do a correction that OR is 15. Please make a correction in the third point. OR is equal to 15. Correction. Correction. Distance OR is equal to 15 centimeter. Please try to understand. Question number 2. Question 2. Circle is given and line A is touching to the circle. Circle is given here. L is touching to the circle. L is touching to the circle. O is a point. Radius is given as 9. This is 9. Radius is given as 9. And point of contact is P. Okay. Point of contact is P. Answer 1. Three questions are given over here. Please make a correction that OR is equal to 15 centimeter. Question 2. If distance OP, what is the distance OP? Distance OP is equal to 9. OP is 9 centimeter, a radius of a circle. Tangent radius theorem. OP is also perpendicular. That is very important. OP is perpendicular to line L. Second question asked is, if distance OQ is equal to 8. If we take over here Q, so that is 8. So OQ is less than radius, because radius is 9. Radius is 9. Therefore, point Q lies in the interior of the circle. Lies in the interior of the circle. Okay, the third one is OR is 15. How many locations of R lies on line L? At what distance will each of them from point P? Okay, so R will lie at two places. Here there can be a R1, and here we can take it as R. OR is 15. This is also 15. So answer of 3 is 2 possibilities. Of point R from point O as OR and OR1. 2 possibilities are there. R1 can be here, R can be here from point O. And they asked at what distance from P. Okay. So in triangle OPR by theorem of Pythagoras. By theorem of Pythagoras. OR square is equal to OP square plus PR square. So OR is 15 square, that is equal to OP is 9 plus PR square. So 225 minus 81, that is equal to PR square. So you will be getting correction is OR is equal to 15. So PR is equal to root 144, that is 12 centimeter. So position of points, position of R and R1 at a distance of 12 centimeter from point P. for this lecture. So you will find here there are two possibilities are there for any point R which is at a distance of 15 from point O. So R and R1. Then I use theorem of Pythagoras for this triangle. Of course, this is also 90. So we find 15 square is 225 minus 9 square is 81. That is 144. So this is 12 as well as this is also 12. So I can say it. So point R1 and R are at a distance of 12 centimeter from point E. So there are three questions. First question was very simple, that what is the distance of P from O, that is 9. Second one is Q is at a distance of 8. So it will lie in the interior of the circle. Third one is what is the distance of point R1 and R from P if R1 and R are at a distance of 15. Using Pythagoras theorem, we get it answer to each. Thanks a lot, dear students. I explained why particular option is correct for MCQs. So all those 10 questions also will solve. See, it is very important. Not necessarily the same questions can be asked MCQs in the examination. Sometimes they change also. So you must know the reason. Simply don't learn the correct alternatives. Please don't do that way. So please try to understand the theory behind it. Thanks a lot once again for listening as well as watching this video of lecture number 67. Blessings to all of you. Thanks again.